Hello, good day, and once again, you are welcome to my YouTube channel. It's our mathematics. Today, in this virtual class, we're going to lay our hands more on some problems. Right on the board, we need to prove by mathematical induction that the sum of the square of all natural numbers is equals to 1/6 n open bracket n plus 1 close bracket open bracket 2n plus 1. So those are the things we're going to look at today. But before then, like I said in the previous class, that in proof by or the principle of mathematical induction has to do with finding a result by not necessarily providing a proof to it. So that is just the principle of mathematical induction. So, and there are also procedure, like I've mentioned in the previous class. The first thing you have to do in proof by induction, show first that what is to be proved is true for n is equals to 1. That's the first thing you have to do. Then, secondly, you have to assume that since it is true for n equals to 1, it is also true for n equals to k. Then, further, that is thirdly, you have to assume or prove or show that it is also true for n is equals to k plus 1. So those are the first thing, the three things that you must do in proof by mathematical inductions. So what we have on the board, I just specify the procedure here. Then let's now go into the operation. So what we are looking at is that the sum of the square of all natural numbers is equal to 1/6 n open bracket n plus 1 close bracket open bracket 2n plus 1. The first thing you have to do from what I've just explained is to see that this is the sequence that is generating the left hand side is n squared. So you must see that it is equals to the right hand side, especially if we put n, assume n to be 1, and if we put it there, both sides must be equal. So the left hand side and the right hand side must be equal when n equals 1. So we see n equals 1 here. So here 1 square. Here we have 1/6. This is 1. We have an open bracket 1 plus 1. In place of n, I substituted 1, or I've assumed that n is equals to 1. Okay. Here we have a 2 times n plus 1. Okay. So here on the left hand side, we have seen, we can see that 1 squared is 1. So here we see 1. Let's see here we have a 1/6. Here 1 times everything here will be 1. Here 1 plus 1 we have a 2. 2 times 1 is 1. 1 plus 2 is what? 3. So in this bracket we have a 2 times 3. Here we have 1 is equals to 1/6 times 6. 6 cancels 6. You cannot see that it is true. So the first thing you have to do here is to show that what you are intend to prove, is true when n is equals to 1 or 2. Okay? So since we have used 1 and it's true, what we need to do is to carry out the necessary operation. So we have to look at the next step. The next step, assume since it is true for n equals to 1, we cannot boldly say that it is also true for n is equals to k. So that is what we do. So in place of in place of n here, we will not be using n, but we say, because we are saying n is equals to what? Let me be very clear here. So we assume that n, that is the next step, n is equals to k. So here we have 1 square plus 2 square dot plus k square is equals to 1 over 6. This is k. Open brackets. We have a in place of k, n, we put k, n k plus 1. Here we have it becomes 2k plus 1. So we have done that. We have assumed it is true for k, n equals k. Okay. Then our next step is that we want to show that it is also true for n is equals to k plus 1. That will be our next step. The next step is to show that it is true for, we want to prove that it is also true for n is equals to k plus 1. And like I said the other time, if we are saying we are going to show that it is true for n is equals to k plus 1, one thing you have to do, you have to look at the sequence that is generating this whole term here. You put here, so you assume that this is the k plus 1 all square, because it's n square, so I will replace n with k plus 1, so it becomes k plus 1 all square. So what you need to do here, to make our work easier, what you need to do is this term here, k plus 1 all square, we will definitely add it to both sides of the equation. So what we need to do is add k plus 1 all square to both sides. Okay, so here it becomes 1 square plus 2 square plus dot 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 plus k square, which is there before, and we're adding this quantity k plus 1 all square. Then we'll go to the right hand side to 1 over 6. This term is already here before. This is k plus 1 to k plus 1 plus k plus 1 all square. Okay, like I said, what you need to do now is just to concentrate on the right hand side. So you just leave this the way it is, and let's concentrate on this. Then if we are to do that, let me write this out clearly. This is 1 over 6. This will have a k here, open bracket, k plus 1, open bracket again, 2k plus 1. You will have open bracket, you will have a k plus 1 all square. So if this term we're going to simplify it, and for us to do it clearly, let me quickly put it here so that we can see it very clearly. This is 1 over 6 k, open bracket, k plus 1, open bracket here, 2k plus 1 plus k plus 1 all square. Now if you can see here, in this term we have k plus 1, on this side we have k plus 1 square. So this k, the k plus 1 all square, also means k plus 1 into k plus 1. So if we do that, what it simply means that we are having a common terms of k plus 1. So that is what we're going to factor out. So it has to be factor at. So from here, the common factor here is k plus 1. So we bring it out as k plus 1. So here we have, so if we remove k plus 1 from here, we'll be left with 1 over 6 k open bracket 2k plus 1. So here we have a k plus 1 square, and we've already removed 1. So what will be left will just be k plus 1. So what we need to do, we need to simplify this. We need to simplify the terms in the bracket. And if you can see here, this is over 1, and this become a fraction. On its own. So, and the LCM of this fraction is just 6. So 6 divided by 6, here we have 1 times k. So the term here will be k open bracket 2k plus 1 plus 6 divided by 1 is 6. So 6 will multiply k, it will also multiply plus 1. So that becomes 6k plus 6. So, okay. Then we need to open this bracket. So, and if we do that, this becomes 2k squared. K times 1, that will give us plus k, plus 6k plus 6, everything over 6. So if we simplify this further, we see that this becomes 2k squared plus 7k plus 6 over 6. So what we are saying here in effect is that this term here, the whole of this term here becomes k plus 1, open bracket k plus 1, then you close your bracket. I'll have a 2k squared plus 7k plus 6, you close your bracket, all over 6. So we are able to, to simplify this. So simplify the whole of this. 1 over 6k, open bracket k plus 1, close bracket, open bracket k 2k plus 1, close bracket, plus k plus 1 all square has been simplified, and the result is k plus 1, open bracket k plus 1, close bracket, open bracket 2k squared plus 7k plus 6, close your bracket over 6. So here we've already known that what we have here is k squared, open bracket k plus 1 square. So we will try now, we want to verify. We assume that k is equals to 1. So the moment we substitute k equals to 1 here and both sides are equal, that means our proof is as good as completed. Okay? So we say k equals 1. So here will be k equals 1. So here will be 1 square plus 1 plus 1 all square. So 1 square is 1 plus 1 plus 1 is 2, 2 square is 4. So you see on the left hand side, the term here, the quantity here is 5. So let's look at this other side here. Here we have k plus 1, which is 1 plus 1, open bracket. Okay. This is 6. Okay. Here is 2, open bracket 1 square, 7, open bracket 1, close bracket, then 6. Everything over 6. So here we let me transfer this to this side. Here we have already known that the right hand side is 5 now. Here we have 1 plus 1 is 2. In this bracket here, 1 square is 1 times 2 is 2. Here 7 times 1 is 7 plus 6 over 6. Okay? Then 2 plus 7 is 9. 9 plus 6, that gives 15. So here we have 2 times 15 over 6. Here, 2 here, 2 into 1, 2 in 6 is 3. 3 here, 1, 3 15 is what? 5. You see that both sides are now equal. So with this, you have shown by induction that the sum of all natural, sum of the square of all natural number is equals to 1 over 6 n open bracket n plus 1 close bracket 2n plus 1. So by mathematical equation, you'll be able to show by proof that it is true. So it is true for n is equals to 1. It's also true for n is equals to k. For now, we'll be able to prove it that it's also true for n is equals to k plus 1. Okay. Mathematical integration is very easy, and especially if you follow the steps that are involved. So the steps, like I mentioned earlier on, what you have to prove, you must show it that it is true for n is equals to 1. Once it is true for n is equals to 1 or 2, then you now assume that since it is true for n is equals to 1, it's also true for n is equals to k. And once that is established, the next step is to see that we want to show, or to show that it is also true for n is equals to k plus 1. So these are the procedures. And please, I want you to assist me in subscribing and also sharing this video to other platforms. There will be people who are eagerly looking for someone to to handle their mathematics. Thank you very much. Thank you for the subscription. Thank you for the share. Have a nice time. Come your way next time with more videos on this, on proof by mathematical induction. Stay blessed.